that would be starting a story in the middle. So sorry, got to briefly go back to the Big Bang, tell you what happened there, show you how the first atoms formed, how the first stars formed, and then we get to Earth, and we'll be ready to look at the way Earth was when it was formed, and the first forms of life on it. So this is exposition, character, and setting. So, when is it? It's, well, you don't have to look at this, by the way. This is just for me. I mean, it's hopefully up here, or it's not going to work. This is just to remind me of what to say, okay? But anyway, 13.787 billion years ago, everything in the universe was crammed into a space. I have a prop for this. Okay. This is a really good little book by Neil deGrasse Tyson, Astrophysics for People in a Hurry. Not dummies. I hate that. Astrophysics for People in a Hurry. Great little book. I read it about, I don't know, 8 or 10 years ago when I had my first knee replacement, I think it was. Anyway, here's the point. See, you can't see it, but you can. You see that period at the end of that sentence?
Yes.
How small it is? Okay, so everybody can kind of see and imagine how small that period is, right? Now, can you imagine? I can't, but maybe you can. Can you imagine something smaller than a trillionth the size of that period? A trillionth the size of that period. Way smaller than an atom. Your average atom's a femtometer across. That's 15 zeros after a minus. This, the universe, was crammed into a space smaller than that. Now that defies my imagination. How about you guys?
Yeah.
But it defies mine, but that's what everything was crammed in. So, can you imagine how hot it was? The actual temperature was 10 to the 32nd power. So that is, I looked it up, and that's 100 nowillion degrees. So that's how hot it was when everything was crammed into a space smaller than a period. And when was it? We don't start at the Big Bang. We start after the Big Bang. And we start at Planck time after the Big Bang. We'll meet Max Planck shortly. Planck time is 10 to the minus 43. So that's where our story begins. After the Big Bang, 10 to the minus 43 of 1 second after the Big Bang. So all the stuff we're looking at is in like trillions and billions of seconds that we're talking about as this unfolds. Denise has put up a graphic to show you, okay, here's what's going to happen. We're going to start out at the Big Bang. Gravity is going to manifest itself as a separate force, and the whole, everything that's crammed into that subatom size there is going to suddenly blow up into almost as big as it is now, and then it's going to stay like that for quite a while, and then after 9 billion years it's going to start inflating again, and that's where we are now. So tonight we'll look at the Big Bang and how things inflated, and as they did, those ridiculous temperatures got cooler, the size got bigger, and as the temperature and pressure went down, all the stuff that the universe is now made of started to partition out. That's what happens. So everything is crammed into one place. It's almost pure energy. It's also almost total order, so there's no entropy. And it's unbelievably hot and dense. And it can't stay like that because it's been pointed out for the universe to be in that kind of shape, be like balancing a pencil on its end. It can't stay that way. So what happened is gravity manifested itself as a separate force, and what that did is cause a phase transition. Now, I got to be careful here, all right? Just because I've learned all these neat new words, I've got to not do what they do on Wikipedia, which is to show how much you learn. I mean, how much you know, right? You ever notice the way people do that? I'm trying to learn something, right? I want to learn what an electron is, so I go to Wikipedia, and it gives me this unbelievable massive jargon. You know what I did? I went to the Particle Adventure. Remember that? I would be downstairs at night, and you thought I was hitting the porn? I was hitting the Particle Adventure. It's a site for kids, and it tells you all this stuff. It's totally cool. Anyway, so the universe blows up. Gravity establishes itself. So we're going to meet at, oh, I got 3 questions for you I was supposed to ask you. Number one, how many people feel they know what an atom is? Please raise your hand. Don't be afraid.
Atom.
Atom. Just an atom. It's not a trick. If you think you know what an atom is, please put up your hand. Thank you. Okay, what about an electron? How many people could define an electron? Okay, good. How about an isotope?
Not really.
Okay, well, I'm glad to hear that, given you're a doctor. Okay, so, nice to see you. Okay, good, that gives me an idea. I think we're pitching it just about right here. I used Denise as a guinea pig, but unfortunately she's sort of smart, so I gotta kind of test it out. But yeah, we're good. Okay, so what we're gonna look at, we're gonna see atoms develop as we go through. We're gonna see the four forces that make everything in the universe develop as we go through. So by the time we get through, and we're gonna have to, I'm gonna really have to move it now, move digression. We're gonna be at the Earth that it is now. You are gonna know what atoms and isotopes are, and electrons and protons and neutrons. Nothing really complicated, well, at least nothing once you know it. And then by the end, we'll all be, hopefully, on the same page. I'm not trying to be patronizing here, but just want to make sure that everybody understands a basic vocabulary. You don't need to know anything much in the way of physics or chemistry for this course. I have felt I had to learn some because I'm the one teaching it, but other than that, I don't think you do. So, there are four forces in the universe. Gravity is the one that everybody thinks they know about, and yet, as we'll find out, this is the one force that nobody knows anything about. They're still trying to find it's what makes gravity work, and they don't know. But we'll look at what Newton thought of gravity, and then what Einstein thought of it, and see what it is now. So, for the present time now, let's just say what gravity is, and it's an attraction between two forces. So gravity establishes itself, leaves three forces still in the mix, but gravity is kind of separate now. And we've got the first particles probably trying to form, but it's still too hot. They don't have any mass yet, and nobody's really forming much of everything. Now, I'm going to stop this part in just a sec. I just want to point out that in that primordial mixture, there were little tiny clumps. And that's all I'm going to say about that at the present time, and then we'll come back to it. All right. What I thought we should do is, as a way to see how we got the science that let us know that the universe is expanding and that it was once very tiny and that it's getting bigger all the time, and that led us to all the knowledge we have, like about dark energy, dark matter, and all the rest of it. Those ideas were already extant in the ancient world. So you've all heard of Pythagoras, right? Okay, the theorem guy, well, he lived in Italy with a bunch of Greeks, and they wore white robes and sandals, and they weren't allowed to eat beans. And Pythagoras said the world is round. So about 500 BC, he was the first to say that. One of his pupils, Philolaus, said the earth is turning on its axis. Okay, so coming out of ancient Greece, we got a round world turning on its axis. Aristarchus, yeah, there he is. Aristarchus, about 2,430 years before Jesus Christ, said that everything is made, I beg your pardon, said that the earth is going around the sun. Most other people thought the earth was at the center, but he said, nope, the sun is at the center and the earth goes around it. Democritus, who lived about 430 BC, said everything is made of atoms. Isn't that something? There's your first atomic theory. What does it mean? Atom, not cuttable, because he thought that these were fundamental particles, right? Okay. He also looked up and he said, those are stars up there, the Milky Way. Everybody else said, no, they're not. They're gods, you idiot. But he said, no, I think they're made out of the same stuff that everything is down here. And he was joined by that and by Anaxagoras and Anaximander. Anaximander came up with the first theory of evolution. He posited that we're descended from fish. And indeed, this one, discovered in Canada a few years ago, was the closest thing we're descended from. We actually are descended from that. Wait till we get to that fish. You're going to love it. If you look at the fins, oh, wait a minute, I'm digressing, sorry. But if you look at the fins, our arms are in those fins. You can see them. You can see, this thing has got a bunch of phalanges here. You can see our fingers. You can see our metacarpals and our carpal bones. There's a radius, there's an ulna, there's a scapula for and what's this one? The ulna, no, humerus.
No.
They're all there.
Wow.
They're all there 375 million years ago. So, gonna be cool. Anyway, so out of the ancient world then, what are these good ideas we've got? A round Earth, spinning on its axis, with the other things going around the sun, just like it's supposed to, made out of atoms, with the heavens being made out of the same stuff as the Earth. These were some of the good ideas they came up with. Well, Aristotle didn't believe them, and the ancient world, do we have a picture of her? Okay, anyway, Aristotle nixed most of them except the sphere bit, and so the next thing that happened was the Roman Empire took over from the Greeks. The Roman Empire fell. The church came along, took the stuff that the Roman Empire took, which was all the wrong ideas from ancient Greece, and transmitted them through the Middle Ages as religious dogma. I'm not trying to be nasty, but the religion said, okay, it said, for instance, it's a great chain of being. This is how the world is organized. God is at the top, then there's 10 ranks of angels up in heaven, seraphim all the way down or whatever, and then down on earth you got the king, he's the head. Over in the animal world, you've got the stag, he's the head, or the lion, he's the head. Over in the vegetable world, you've got the oak tree or whatever, and in the animal world, you've got the lion, and in gems, you've got diamonds and gold. And that's how everything was set up, was this hierarchical universe. And that's the wrong ideas, the non-scientific ideas that came out of the ancient world. All right, now we're going to get 1543. Moving right along here. Oh, that's not the number of the slide, huh?
No, I know, I know.
Okay, Denise
Don't
knows
worry.
this stuff pretty well. If you've got any questions, address them to her. In 1543, Copernicus, oh, what number do I want? Just a second.
Don't
10.
worry
Number
about it,
10.
dear.
Okay, that's Nicholas Copernicus. Wasn't his real name, but everybody in those days took Latin names. Like, it wasn't enough to be a scientist in those days. You had to write your friggin' science up in something like Latin or Greek. Can you imagine? I can't. I took Latin for 3 years. I'm actually glad I did, but that way I've got a good excuse for not understanding French. But anyway, what happened to this guy, Nicholas Copernicus, was that on his deathbed in 1543, he put out a really important book in which he said definitively and beyond the shadow of a doubt that the Earth was the center of the solar system. Everything else was going around it. And if you don't like it, too bad, because I'm dying. So that's what he did.
No, sun is the center of the
Yeah, what did they say?
Earth.
Oh, did I? Oh, thanks. Okay. He said the sun's the center of the universe, and then he died. Nobody could do anything to him. But let's look at Bruno, number 12. Now, this guy's a contemporary of Galileo. He said the same thing that Anaxagoras and Anaximandra did. He said, everything out there is probably the same as here. And there's no reason to think there's any different laws. There's probably other suns and other planets. There might even be other life forms. Well, they burned them at the stake in 1600. So, the church was serious about the dogma. Now, yeah.
Were these just theories that
Sorry.
they had? They're theories that these men had. They had no scientific proof.
That's right. But
They're
questions at the end, okay?
Yeah, questions at the end. I mean, I'm my own worst enemy for digression, so if you guys ask questions, I'm really sunny, right? So, yeah, so they burned Bruno because he contradicted church dogma, which they took extremely seriously. Galileo had to be aware of that. Now, Galileo, oh, interestingly enough, he was born in 1564, same year as Shakespeare. To me, everything revolves around Shakespeare. So 1564, Shakespeare is born, so was Galileo. And he died on January the 8th, which was the same day that Einstein was born. Isn't that something? Yeah. Anyway, so Galileo died January the 8th, had this telescope. They had invented a microscope in Holland not too long before. Then they found that if they grounded a different way and pointed a different way, it became a telescope. So Galileo had made a telescope, ground the lenses themselves, turned it up to the sky, and what did he see? He saw the sun. Okay, that's fine. But what did he see? He saw spots. Sun's not supposed to have spots. The sun is supposed to be a perfect orb. It's perfect, it's eternal, it's unchanging, and it's set in the heavens. Up in the heavens, nothing changes. Up in the heavens is where you hear the music of the crystalline spheres. It's got luminous ether in it, around which light is transmitted, and the happy gods whose blood, well, it's not blood, it's ichor, are enjoying themselves up there. And meanwhile, everything's supposed to be perfect. Galileo turns his telescope and he sees big pimples on the sun, sunspots. Then he looks at the moon, which is supposed to be a crystalline sphere of pure whatever, and it's got mountains and craters all over it. Holy smokes. And then Saturn, rings around Saturn. Okay, what the church has said is that everything up there is perfect and unchanging. But what Galileo is saying is things are changing all the time. And instead of being this perfectly ordered bunch of perfect circles, nothing is in perfect circles. And this guy, Kepler, number 11, sorry, hon, put it out in a book in the 1600s. One of the more important books ever read. What Kepler did was he improved on Galileo. He said, yep, the sun's at the center of the solar system, the earth and everything else revolves around it, but they don't go in ellipses. See, what happens if you look at a planet in the sky and you trace its movement in the sky, it goes along and then it goes like that. So the ancient Greeks had to come up with a way of dealing with that. So a guy called Apollonius invented the epicycle theory, which says, well, that's the way the planets go around the, you know, the sun. Now, Copernicus still believed that, but Kepler didn't. So Kepler said, and it was right, and so this is true, the planets don't go around in perfect circles, they go around in ellipses, and nothing up there is lasting forever. It's just the same as it is down now. Galileo also looked at light. He was smart enough to realize it was a thing, and he tried to measure it, like how fast it went, but he was unsuccessful. He also didn't believe Aristotle. Aristotle said that heavier objects drop faster than light ones. And if I dropped a feather in this, the feather would take longer to go down. Of course, that's due to air resistance, right? So Galileo actually proved, without a vacuum chamber, that that's not how gravity works. He rolled a ball down a series of ledges and found that the smaller ones rolled just as fast as the big ones. And so, hey, he was a cool guy. But he started going to parties and blabbing about what he was seeing. Wrong move. So the church came along, arrested him, put him on trial, found him almost guilty of heresy, and sentenced him to house arrest. So he died a lonely, blind old man in his house. Probably better than going up in flames. That wasn't very happy. This brings us to, you all know who Neil deGrasse Tyson is, right?
Yeah. Yep.
Hi there. Okay. Do you don't know who Neil deGrasse Tyson is?
Oh, yeah.
I'm in deep shit. Oh, anyway, he's the guy that wrote that book that I showed you, the period. Here's that black African-American guy that's the science popularizer. Anyway, he's this huge Einstein fan. So they asked him, who's the greatest scientist of all time? Without hesitation, he said, Isaac Newton, smartest man that ever lived. So, I'm not going to try to tell you about what Isaac Newton did, because let me show you what happened. I went downstairs. Yeah, here it is. I said to Denise, I'm going to go down and write down some of the more important stuff that Isaac Newton did. Well, I started writing. I kept writing. I wrote some more. Some more. Some more. This is just on Wikipedia. I wasn't even writing everything. I finally gave it up. But let's just address with three things: light, gravity, and motion. In terms of light, Newton had, oh wait, let's look at the apples first. Okay, 1665, Cambridge University is shut down. Newton can't go because there's a plague, right? The plague used to come through England all the time, bubonic plague. The good thing was that next year there was a giant fire and sort of sterilized it by burning down London. But anyway, Newton's at home. He's been sent home, so he's at home in Woolsthorpe. Looks at the tree. He claims this is true. The apple didn't hit him, but he saw an apple fall. And he thought, I guess along the lines of Anaxagoras and Anaximander and those guys, and Bruno, that hey, as above, so below. Whatever is making that apple fall to the ground is the same force that's making the moon go around the earth, or the earth go around the sun, or whatever. So every great scientist